What's the effect of oxygen on the aging? Control, or how do you control storage conditions? Data loggers, well, we started with one. How germplasm and breeding lines are stored. What if the seeds have aged? Can you revive them to some extent? There is some possibilities. And about the storage of primed seeds. So as I said this morning, most of our the seeds, at least the seeds where we work, have no problem to being dried, and it's best to store those seeds on the dry conditions. But if the seeds are recalcitrant, then it is then you need other storage conditions. So this is the gene bank in Fort Collins. That's the main gene bank in the United States of America, where they store embryos from recalcitrant seeds. So they do not store the entire acorn. They isolate the embryo and they store it in liquid nitrogen, like semen from animals in storage. So it's a very expensive way of storage, and if you want to get a plant out of that, it has to start also through tissue culture. You cannot put that embryo without a cotyledon, so it's only the embryo part, small parts. You cannot revive that normally in sand or filter paper.
So it's minus 250 degrees?
No. Almost minus 200. Yeah, it's not absolute zero, but it's very cold. Yeah. Okay. Well, how long can a seed survive? The seed that can be dried. Now, the record, for which we are sure, is about 2 millennia, and that was a couple of years ago, 2005. It was this publication. Then before that, in an excavation in Israel, they found 3 seeds from date palm. And radiocarbon dating, they could detect that they were about 2,000 years old. And from these, they also had to use some tissue culture, but they could get 2 date palms from those seeds, so they were still alive. Not at a very high quality. They used tissue culture, but this is the record for seed storage. Well, I don't think your seeds need to be stored for 2,000 years, but this is really it's quite interesting that this is possible. But there is variation between species, but also within species there's variation. This morning I told you about the rice. With the red rice, we can keep it longer in storage than non-red rice. And that's because of the antioxidant activity. Yeah. Well, if your seeds are stored, this is, I analyzed here different seed lots from lettuce. From seed lot which was different age, from 1, 2, 3 till 5 years, and we did the germination test. And the blue bars is the seeds that gave a root. So the germination is what we call when we put a seed on filter paper and we see the root, embryonic root protruding. That's not a seedling. And when a seedling has a good quality, and that is here the upper photo, then we call it a normal seedling. As you see here at the bottom, those are seedlings from an old lettuce seeds. So there we see that we see what is typical for lettuce. I don't know if you can see it, but there is this brown dots, which they call mid-vein necrosis. So apparently the cells in this area, I think that the membrane is damaged, and those cells are dying. So this is typical. It's quite typical for lettuce. With other, if you think about cabbage, if they are old, the seeds, then you might see some chlorosis, some white areas on the cotyledons. Yeah. So you see, they still germinate after 5 years, but you do not get any good seedlings after 5 years. And even after 3 years you get some, and also after 2 years all are still good seedlings, but the germination is more slow. So what you first get, what happens during this aging is there is damage is accumulating. Well, the seed, the first thing it does is to produce energy and to repair damage. For the energy you need the mitochondria activity, and then the damage is repaired. Damage to the membranes, for instance, damage to the DNA is repaired, that breaks. That takes time. So that's why the seed which is aged, which is stored for some time, will germinate more slowly. It will take more time before the root protrudes and more time before you see the seedlings emerging above the soil. So that's a slower germination. Then you will see, if it ages more, you see more abnormal seedlings, like that. And if it takes longer, you see less seedlings emerge. So they may germinate, but you will never get a seedling above the soil. Even longer, less germination, the root doesn't even get out. And at last you see no germination at all. It may be that at the start, if you put the seeds, some cells are alive, you've made the seeds wet, but they cannot prepare enough, and in the end they give up and they die. What is also often happening with seeds is that the cell membranes are damaged and you get leakage. So if the leakage is there, especially sugars, amino acids are leaking, the fungi love that and they will grow on your seed. You will see that especially when it's on filter paper. So this is what we see during aging. Well, if you look more with more other ways, in more details, and what is happening, is the first thing is that one of the things you see that these membranes get leaky. For instance, if you put pea seeds in water, and you have good quality pea seeds, and and there is hardly any leakage, and you put your electrodes in the water, you can measure the electric current. If the water is salty, the current is much easier from the one pole to the other. So that's what they call conductivity, electroconductivity. If the pea seeds are aged, you can measure that the conductivity is increasing, so that it's much easier to go, there's much more ions leaking in the water. So, and that is because the membranes damage. Also the mitochondria, they have a double membrane system, maybe you remember from high school or later. Mitochondria has two membranes, the outside and the inner side, which is very much lobed. And in the inner membrane, there is a proton gradient which is needed to produce the energy, the ATP. And that inner membrane contains a lot of unsaturated fatty acids, and as you know, those are prone to oxidation. If you take your sunflower oil, if your bottle is almost empty, if you look at the top, it is oily, sticky there, and that is because it's oxidized, the sunflower oil. That's because the unsaturated fatty acids, they oxidize. What is also known is that that's research from 50 years ago already, that they looked at chromosome separations, those pictures, and they saw that there were strand breaks also in the DNA. The older the seeds are, the more breaks in the DNA. Proteins are oxidized, so that is what it is. Well, these needs to be repaired for the seeds to function. That takes time, so that's why we have this slower germination and emergence. And it's also more sensitive to stress. If we are ill, we are also more sensitive to other stresses. If total repair is not possible, then we get these abnormal seedlings. Or even they do not get above the soil, no emergence. So this one we have seen this morning. So at high humidity, the aging or the deterioration of the seeds is mainly because of mold growth, which are growing, and the mold can also produce enzymes that attack the seeds and the root system. Insects can also give damage. They can even at the low humidity can be active. But if this is not the case and the seeds are dry, then all damage, in fact, what there is oxidation of the proteins, the lipids, the DNA, RNA. And lipids is not only the lipid, the storage lipids, but this is also the membrane lipids. So the seed aging under these dry conditions is mainly due to oxidation. Like with your iron tools, it is stimulated by humidity and it is stimulated by high temperature. But it is also stimulated by oxygen. That's why, maybe you remember from evolution, it took a long time before when the plant started producing oxygen, that was really a problem for other organisms because there was so much oxygen in the air. So we have to develop systems to prevent oxidation of our organic molecules in the organisms. So also for seeds, oxygen is a problem. So, well, this is a graph from food science. This is 50 years old graph, and there are important things. So this is the relative humidity, not moisture content; it's relative humidity at the bottom. So what you see here is that at above 70% relative humidity, molds can grow, fungi can grow. They grow faster at a higher humidity than at a lower range, but they can grow. Also, enzymes can be active, and they can be more active when there is more water. And there is a difference. Some enzymes need a very little amount of water, and other enzymes need more water for their activity. And the third thing we see that this is the lipid oxidation. And they measured with the food different relative humidities, and they observed already that lipid oxidation is higher at a higher relative humidity. It goes down, but it also increases again when it is a very low relative humidity. And that's what we call ultra-dry seed storage. And ultra-dry seed storage is not favored. I told you this morning that the optimum is around 30% relative humidity. Well, it is also here. You see, this is also can be 10 to 30, but there's not so much variation. And of course, it's easier in a warehouse to keep it at 30% humidity compared to 10% relative humidity. So I will come back later to this ultra-dry situation. But you see that oxidation is faster with food when it is at 70% relative humidity compared to 30% relative humidity. And so it's not straightforward. You have this ultra-dry situation. Okay, that's what I told. And it goes slightly down here, above 70% relative humidity, and that has to do with enzymatic antioxidant activity. That can happen, and also in seeds above that humidity. So this picture, again from this morning, where it is important, that's why we work with the relative humidity and not with the moisture content of the seeds. Because this is in the cytoplasm where this oxidation is occurring. It's also in the lipids, but the lipids area does not depend on the lipid bodies, does not depend on the relative humidity.
One question.
Yeah.
Let's say that we get the seed to 30% with relative humidity, everything okay. Then the refrigerator or the warehouse opens and the humidity goes to 90%. We get back there, we see that the seed is 90% relative humidity, you know that we will lose the game, and we getting somehow back to 30%. would it be okay for the seed?
If it's not too long, so if it's long, then you may get fungi growing. But if
Long
it's
1 day or
one
1
day,
week?
I expect it's not too much a problem.
Or a month or something?
On a month, if it's a month, you get fungi growing. But in 1 day, the fungi
And what happens when you get it back?
they will dry again.
They will dry again, but are they damaged already?
There are some publications that there may be even some repair occurring. If you're temporary high,
Yes.
the enzymes can be active,
And so they make repairs.
and they can make, that's the idea, they can make repair. There are publications where they stored seeds from foxglove, they stored them, then they gave them, so and they aged them, so they were slightly deteriorating.
Yes.
And they looked what is the germination going down. Then they did them for, I'm not sure whether it was 1 or 2 days at a high humidity, and then back, and then the germination was better
Oh, really?
for foxglove. It doesn't say that it works for all seeds.
Yes.
Yeah, so it is not by definition that this is bad, but a long time at 90%, that's bad.
But if it's not 90, it's 60 or something, 70.
Well,
for a month.
then you have more oxidation
Yes,
than at 30.
yes. But the real question is, okay, the humidation rises up, the seed is damaged, let's say a month.
Yeah.
Okay, and then you find it out and you go back the seed to dry him again. Will the damage stop there, or the seed already
It's
finished?
it's not that it stops at 30. The deterioration doesn't stop at 30. It's just at a slower rate. It's not that it stops. If you put your seed at 30%, doesn't mean that you. I showed you this example with the lettuce seeds. They were stored at 30% relative humidity. But if you take a tomato seed, that doesn't age that fast like a lettuce seed. Lettuce seeds age relatively fast.
Yes.
And onion seeds and leek, they age fast. But tomato seeds, you can store much longer. Yeah.
Well, I stored the tomato seed with not moisture content, something like 11% in a fridge, 10 years, no problem.
Yeah.
11% for the tomato seed is high.
Yeah.
You need 6 to 8 something.
Yeah. Yeah.
But in the fridge, no problem, 10 years.
Yeah. They still germinate.
Yes, generally good.
Yeah. Okay, so the relation between relative humidity and moisture content, well, that is these are those graphs, and these are typical two-seed spinach, which doesn't contain oil or hardly any oil, and brassica, which contains a lot of oil. And oil cannot take up water, that's why the moisture content is lower and the same relative humidity compared to the spinach seeds. So there's moisture content. With seed science, we often work on fresh weight basis. So we sell seeds, 100 gram seeds, and from the 100 gram, 12% is water. So that's the moisture content is 12%. In the food science or in more scientific studies, they do it on the dry weight basis. So this is the weight dry, and this is the water which is in. But you can calculate those, but it's important if somebody talks about moisture content, is it a percentage from the fresh weight, or is it a percentage from the relative to the dry weight? There are some general rules for seed storage, old rules already. One rule is that the temperature in Celsius and the relative humidity together should stay below 60% for good seed storage, below 60. Harrington, that's another rule which is already 50 years old, said that the longevity decreases by 1/2 for every 1% increase in moisture content. So that means that if a seed after 1 year has a certain decline in quality, that it, if you increase the moisture content, if you decrease, if you increase the moisture content by 1%, then you reach the same poor quality in half a year. So that's faster. So that's the Harrington's rule. Or if you increase the temperature as well. These are very general pictures.
Yeah.
These are the pictures for rice seeds. This is a theoretical pictures. Researchers have done for several species. They've done storage experiments. They stored seeds, in this case rice, at a certain temperature and a certain humidity. And this for different temperatures, different humidities. And every 2 or 3 months they took a sample and looked at the germination. And from that, they could calculate for that seed lot its relation with the temperature and its relation with the humidity. And there is a formula for that. I don't want to bother you with the formula, but using that formula and these constants, which are determined in that experiment, can tell you something about what's the effect if I increase the temperature. What is if I decrease the temperature? How long can I store the seeds till the germination drops below 90%, for instance? Well, here you see clearly the effect of moisture content with rice. This is the green is the rice at the 12%. Remember the rice department where they store the seeds. They dry the seeds to 12% moisture content in Thailand, and then in these woven bags in the warehouse, which was not completely closed. And then you'll see that if it increases to 40%, that it really drops fast. In a half year, you go to around 30%. What is left? Well, this is the effect of the different moisture contents or humidity levels. And that is why seeds are optimally stored. Like this is for the storage for the expensive vegetable seeds. Vegetable seeds, they are stored at 15 degrees Celsius and 30% relative humidity. It's where the big vegetable seed companies in the Netherlands, how they store their seeds. So these warehouses are conditioned. In the middle we have maize seeds. They are dried to, well, let's say, I don't know exactly, but maybe 12% moisture content, and then they are wrapped in plastic to at least to reduce humidity uptake. It's not hermetically, but it's much better. Then on the right picture, that is the warehouse in Thailand with the woven bags. It's more easy to absorb moisture. But of course, the left one is much more expensive, such a warehouse. Sorry, and so this is it's high volume seeds, and so it's not economically feasible to store them in a warehouse under these conditions, in the conditioned warehouse. Okay. This is a picture I took when I was in Turkey on a conference, and this is the way the seeds were stored there, or at least on the market they were there. And I assume that when the shopkeeper is closing his shop, he just put them this way, just back in the shop in this way. Well, this is not. The seeds are likely very cheap. But of course, the farmer doesn't get much quality for those seeds. Well, this morning I talked about the effect of lowering the temperature on the relative humidity. So storage in a cold room, when it's not hermetic, when it's in a paper bag, for instance, is not recommended unless you have in that cold room the humidifier. The humidity is lowered. But most cold rooms don't have that. Some have.
So it's better to have it just at the warehouse instead of the cold room? No.
if you can keep the equilibrium relative humidity to 30%, then you may use it. If you put it in a glass jar or these aluminium foil bags sealed, then you can put it in a cold room.
Otherwise, no.
Not in a paper bag. If the humidity here is 90%, then your seeds will deteriorate fast. If you put it in a paper bag.
The fridge is always drying things. It absorbs humidity, the fridge. It doesn't generate, even if we think, most of us think so, it's wrong.
That depends very much on your refrigerator. Some refrigerators have a high humidity, some old refrigerators have condensation of the water, so ice formation.
Yes.
But modern refrigerators don't have that. And so that's it depends very much on the refrigerator. I would not gamble.
So no
on,
paper bag, but oven.
Also
in the
not.
fridge?
No,
No.
oven is the same as paper.
Only air sealed.
Yeah. Yeah, so, and not in plastic, which is permeable for water vapor. So it really should be, water vapor should not be able to enter. That's it.
And then when you take them out, you have to kind of gradually climatize them to the temperature outside.
Yeah.
Because
If you open them immediately, water vapor will condense on the seeds. Yeah, you're right. That's also some issue. Yeah. So important, make the seeds dry and keep them dry. That's what we had also the message this morning. Then about the role of oxygen. I told you that in dry seeds the main damage, if it's not the insects, it is oxidation. Cell membranes, mitochondrial membranes, you get leakage, energy production is hampered. And that's why is that? And this is the oxygen molecule. And this oxygen molecule, if it touches a metal, can be iron, can be other metals, then it forms so-called reactive oxygen species. And the reactive oxygen species, they react very quickly with organic molecules like the unsaturated fatty acids and oxidize that. So oxygen is the main source for reactive oxygen species in biological systems. Oxygen is dangerous. So when you put seeds, I put seeds in a jar, and I measured in that jar the oxygen level. I can do that. We have a system where we can put on the inside, we can put a dot, a chemical, and if we eliminate that with a blue laser light, short flash, then it fluoresces, and the fluorescence slowly declines. And the rate of decline can be measured, and that tells something about oxygen concentration. So with that device, I can show you tomorrow on the lab if you're interested. I can measure what is the oxygen level in the jar. So I put lettuce seeds in a jar, small jar, and I measure the oxygen level. Of course, I started with air, and this is the time in days. So you see, after about a year, and this was stored at 20 degrees, and the humidity was, I think, around 40% relative humidity. You see that in about a year, 2/3 of this oxygen is absorbed by the seeds. Well, that can be respiration, like maybe indeed they have a very low level of respiration, or it can be oxidation. So, for food science, we know that the reactive oxygen species, they oxidize macromolecules like the proteins, the carbohydrates, and the lipids. And we also, if you buy a bag of peanuts or walnuts, you can read on this that it is packed on the nitrogen gas frequently. And these bags, this is with aluminium foil. Why is this aluminium foil? Because if you have only plastic, oxygen can go through most plastics, but not through a layer of aluminium. That's why coffee is also used to be packed in bags with aluminium to prevent oxidation, because then the taste deteriorates. And for walnuts, nuts, it is the rancidity that increases, the rancid taste. That's oxidation. Nowadays they have for coffee also other kind of packaging material, which is impermeable for oxygen without aluminium. But you still see mainly this aluminium is used. So they store the walnuts and the nuts under low oxygen. Well, this is what is happening here. We have the lipids, and the lipids get. We have here unsaturated areas in the lipids and the lipids. So this is a lipid with 3 fatty acid chains, and here the oxide, this radical will react with this double bond, and you get oxidation. And in fact, what happens is that oxidation results in a new reactive oxygen radical, and gives a new oxidation. In fact, this is what they call autocatalytic lipid oxidation. So it continues. One reactive oxygen radical can generate more new oxygen radicals. That is what they do. So oxygen is really dangerous, and this gives this rancid taste if the walnuts are old. And if oil oxidizes, well, this is oxidized oil going from a liquid to a very solid phase, solid state. I don't know if maybe in your own kitchen or when you were a student, there was sometimes oil drops on the wall, and if they are there for some time, it's much more difficult to remove them. And that's because of oxidation. That is what is happening. And this is those are not flexible. So if it happens to the biological membrane, also the biological membranes get less flexible. Yeah, Frank?
Just to sum up what also you said before, this means that oxidation is the factor that makes the cell membranes less flexible, so they get leaky.
Yeah.
This is part of the aging process of
Yeah.
the seeds.
Yeah.
Because the fatty acids that are unsaturated get saturated through this oxidation process.
Yeah. And if they get saturated, they may even get cross-linking.
Okay.
It's also something what is happening, and then they get less flexible, and then and when you put them in the water moves. There's a big water potential difference. The water goes with a very high speed and pressure through, and they're less flexible, so they have difficulties in closing. That's how they envision also that seeds are sensitive. And when it's cold, they are even less flexible to temperature, and that's why seeds are sensitive to inhibition in cold water, especially aged seeds. Yeah. So when I was in Thailand on one of these courses, then I should see the academy about a package of pumpkin seeds, and on the package was written nitrogen packed for freshness. So they package the seeds under anoxia, remove the oxygen. So and then I had the same question like this morning. Why do they store the seeds under anoxia, and why do the Rijkswaans do not store their seeds under anoxia? So I asked them, are those seeds more valuable, that they put this extra economic efforts in there compared to your seeds? No, they said our seeds need to stay alive. To stay alive, they need oxygen. Well, like this morning, I questioned, if a seed is dry, there's no enzyme activity. For respiration, you need enzyme activity, so I think there is no respiration. So let's test. What happens? So what I did, I forgot that. Celery seeds take a long time for germination. So commercial celery seeds are most often primed. Still running?
Yeah, all good.
Yeah. So celery seeds are most often primed. But primed celery seeds are known for a short shelf life. You cannot store them that long. So, so I said to next time I'd like to do an experiment. And do you have primed celery seeds for me? And then I can do an experiment. Well, they had these seeds, and they were also pelleted. That's what you see here. So these are the primed seeds with a pellet to make the sowing easier. So I got seeds. Part of those seeds I stored in laminated aluminum foil pouches, like in our gene bank, for 3 weeks at -20. Well, the seeds I got from Rijkswaan were already 2 weeks old, and well, you see some of them, well, they germinate, but the seedling quality is not that good. There is some variation. Another part I stored in a glass jar, like you did this today, just with air and at 35 degrees Celsius, so quite warm. Well, indeed they did not survive. So you see they survive much better at low temperature. And then I stored them with drying beads and an oxygen absorber. And look what is the quality. Also at 35 degrees Celsius for 3 weeks. And this oxygen absorber, which is iron powder, takes the oxygen out of the air within 24 hours. So those seeds were almost 3 weeks without any oxygen. I did also, I have not here, with only oxygen absorbers. They died, and that's because oxygen absorbers also contain a moisturizer to stimulate the oxidation of the iron powder and thereby capturing the oxygen. And that's why that moisture I removed with the drying beads. We checked later, oxygen levels go down anyhow fast, even if the drying beads are there. So for me, this showed that they can survive very well without oxygen, at least for the 3 weeks. And they do well, and at 35 degrees Celsius, they even do better than the ones that were stored in the freezer. So then we got interested in what is the quantitative effect of oxygen. What happens if you use half the oxygen concentration? What happens if you use 1% oxygen, even lower? So, and this is the result of an experiment that lasted, you see, in weeks, that's 3 years. And even the experiment is still running, that experiment. We
No.
This is different.
No, yeah.
This is different oxygen levels. So these are different oxygen levels. So we dried the prime celery seeds, 30% relative humidity, and we stored them here at different temperatures. But here I showed at 20 degrees. In a jar. We flushed with pure oxygen, and what you then get, because it's very difficult to get the last air out. 1% oxygen. So you see that's the purple line. They age very fast with 100% oxygen. The blue one is the air. So you see that after about 20 weeks, they have lost half of the germination capacity. We looked at root protrusion here. And this is the line where we flushed with nitrogen gas. Mm-hmm. So we estimate about 1% oxygen. So you see there is a very big effect if you store the seeds with low oxygen levels. They still age, but much slower. And we calculated that the effect of oxygen is every time you halve the oxygen concentrations, the shelf life increases by 70%.
70.
70.
Wow.
So if you halve the oxygen concentration, and it's not too difficult to go to 1% oxygen if you use oxygen absorbers or
So-
flushing with nitrogen gas.
The question we had in the morning, what if we take an aluminum bag, foil for example, we put in the seat and we take off the air? Because there are cheap machines that they can take off
Yeah, vacuum.
the air, vacuum,
Yeah,
to make it vacuum. It's the best solution
yeah, that's a very good solution.
for long storage.
Yeah,
Okay.
it's better to flush with nitrogen gas, that's even better. But already with vacuum, you remove large part of the
Yeah.
oxygen. Yeah. This is, so, two messages. One, dry seats do not need oxygen to survive. And the second message is that there is a quantitative effect. If you put both on a logarithmic scale, the oxygen concentration and the survival, I don't have it here, it's a linear line. So it's a log-log relation. And also at the other temperatures. Yeah.
But so then it's very important to know that really your seats are dry, and then how can you really ensure, how can you measure this in an easy way?
Well, that's what you started at the third experiment today.
Yeah.
In fact, either you determine the water activity with that expensive device, or you measure with a relative humidity meter what are the seats dry or not. It is essential indeed that the seats are dry. If their humidity is above 70% relative humidity, then they may start respiration and need oxygen.
And it was between this 10 and 30 relative humidity percent.
Well,
which
this is
an
30%.
ideal range. But you were showing that graph for the liquid.
Yeah, but it's ultra dry
oxidation.
storage. Yeah, that's another other point. I think we have some time. Let me see if I'm getting thirsty also, if there is already the tea.
Only for this is not working, isn't it?
It's my throat. So maybe let's stop and let everybody have some tea and coffee, and then I tell about
Yeah,
about that.
I was thinking that we were bringing samples since they things like that.
Now you brought the samples. I tell you a story. People have, I think that was in the 60s, 70s, they did experiments storing seeds ultra dry, and they found what food science also told: if you store them very dry, they deteriorate faster. Because we have this seed viability equation, which is constants from different species, and if you follow that, the drier it is, the longer they store. So they check that. Well, that does not hold if you go very, very dry. So then there was a Professor Gomez Campo from Polytechnic University in Madrid, and it will be now around 60 years ago, that he collected germplasm wild brassica species. At that time you had these glass reaction tubes. So what he did, he made the seeds very dry and put them in the glass reaction tubes and flame sealed them and stored them for 40 years. And after 40 years he opened some of these tubes, and he found that the seeds were very well germinating after 40 years. It was not in the fridge he stored them. So he said, well, you should store your seeds very dry, because that's what I did. So he went visiting gene banks, giving stories. You should store your seeds ultra dry. So then the researchers from Fort Collins, the gene bank, they said, don't listen to that man. Don't do that. That's damaging your seeds. Well, he had his experience, and they had their experience. and both were scientists. They did it good. So I was at the gene bank in Poland when I gave a lecture, and he also gave a lecture. And then I asked him, "Did you change something in the gas in your tube?" I said yes. And he did. I put it in a box, and I put carbon dioxide. You have this dry ice on it, so likely there's carbon dioxide in it, and then I flame sealed it. It was not in his publications, and he never told me that. Later the publication was told. Well, even if it was not that, I showed you about the oxygen in the lettuce seeds, that the oxygen level anyhow dropped, but with this carbon dioxide it was sure there was much less oxygen. And later unfortunately the man died already, but they published that this was carbon dioxide. And we also have now experienced that if there is no oxygen, then this rapid ultra at low level, high level of oxidation is hardly occurring. Then you only have this autocatalytic lipid oxidation, which may happen. But if you have enough antioxidants, that they stop that autocatalytic lipid oxidation. Seeds contain a lot of antioxidants, especially vitamin E. That's a lipid-soluble antioxidant, which is in the membranes. So that's about this ultra dry. Yeah. So that's yeah. So it has oxygen has a lot to do, and then so I found that seeds under very low oxygen concentrations live longer, and when you look into there's never experiments been done. Yeah, experiments were done. In 1961, so that is more than 60 years ago, there was a publication from Eric Roberts, later Professor Roberts, who could be in fact the grandfather of seed storage research. He stored rice seeds at 3 moisture levels, and under carbon dioxide, nitrogen gas, air, and oxygen. And he observed with under drier conditions, that indeed the rice survived better under nitrogen. Carbon dioxide slightly better. Under oxygen, they died faster. So I wondered, why is it still not? We know that already for 50 years at that time. We know that, so why is not that done? And then I looked in other literature, and sometimes they found positive results, it extended longer, and sometimes negative results, sometimes no results. So I wondered why this variation? And then I think the clue is that the main seed research was done with arable crops. And how are arable crops stored? Often at a much higher humidity. And 1 year ago there was quite interesting publication from a group from Austria. They showed that this oxygen effect is only there when seeds are dry with a so-called in the glassy state. In the glassy state, it's not that, I can tell it here, it's not that I want you to tell it to your students in your training, but since you're large part also academics, I told you the cytoplasm contains a lot of sugars. Well, think about a lollipop. Yeah? That is sugar. But it's not a crystal, it's a glass. You can look through it, but it's a glass because, and in the old days, this of glass still it is not solid. It has a very low mobility. If you look at very old glass, it is thicker at the bottom compared to the top. That's why they call it a glass. But it's a very low molecular mobility. And that is what seeds have also in the dry conditions. If you go above 60% relative humidity, can depend on the species, then this glass melts. Like a lollipop, if you wet it in your mouth, it melts. And then it is much more mobile. The molecules can move much more in there. And then there is not so much an effect anymore, that's what they showed, of storing seeds at a low oxygen level. Then it doesn't help, this low oxygen level. So that's likely the reason. Most of the research, large part of the research that had been done with low oxygen storage was with agricultural crops and not under low moisture conditions, low humidity conditions. But now I see that this I put it again for the seed science and also for practice on the table, and now we see that that companies are taking this over. Some companies even built a warehouse, complete warehouse with very low oxygen levels. That's yeah. I think then you need automatic systems for seed picking.
Yeah.
You cannot put people in there. But the consequences are very large if you lower the oxygen. But there are other ways to reduce oxygen levels, and I will show you. So one way is indeed the oxygen absorbers, but the packages are small, for 1 liter or something like that. You can flush with nitrogen gas or carbon dioxide gas. I would not recommend carbon dioxide, because carbon dioxide is an acid. And there is some water in your seeds, and so you can get acidification. And we are now doing some experiments with cacao beans, which are already dead, transporting, and also the taste differs whether it's transported on the nitrogen gas or the carbon dioxide. And like just said, vacuum packaging is another way that you can reduce the oxygen concentration in the packaging. Well, then, of course, you should keep the oxygen concentration low. Well, we flush with this glass jar, we make a hole, 2 holes in the lid, and we flush with nitrogen gas, and we close it with some sticky aluminum tape, and we can measure it, so that's easy. This is the aluminum foil pouch, so impermeable for water and impermeable for oxygen. These things also. This is a big bag. In fact, there are 2 big bags. It's an outer bag and an inner bag. I will show you tomorrow. The inner bag is a material, different types of plastics. I think 3 different types of plastics, and together they make it impermeable for oxygen. This is used in the food industry. I had once, this was a consultant for a seed company in the tropics that was doing well, and they needed to expand the warehouse. But that's very expensive. And in the tropics also electricity, so power cuts are frequent. So I suggested to think about the possibility of storing their bulk seeds in these type of bags. Dry them to 30% relative humidity and store them without oxygen. Flush and store without oxygen. And then, then the temperature is still 30 degrees in the tropics instead of 20, what was the normal warehouse. But the warehouse was much cheaper to build and didn't require electricity for maintenance of the relative humidity and the temperature. And that's what they did. So economically it was this was for the bulk seeds. So as soon as they need it, they empty it and could do a germination test again. They're very happy with that system. Now they are also flushing the packages for the dealers. Dealers have no control of temperature. They used aluminum foil packages, no problem for that. But the dealers, anyhow, it's 30 degrees, and sometimes the dealers put it in a display in the full sunlight. Hot. So they have an expiration date on these packages. And after expiration, the seeds come back from the dealers, they put it together, they do a germination test. It's thrown away because the quality is not good. Since 2 years they flush with nitrogen gas. No, longer even. And now, when it comes from the dealers, they told me from return, they test, they just mix it with some new seeds, it goes in the package. So again, it saves a lot of money for that company, but to me what is even more important, think about a farmer who buys that package 1 month before expiration date. It's still good, but think about the quality, about the germination and the vigor for those seeds. So that is, if you think about your seeds, and we were discussing also during the break, and I think this is, you do put so much effort in producing a good quality seeds, that you will produce even with what we learn here, what you learn with your experimentation, you do more. And you dry the seeds, but so much quality can be lost during storage. And there are mechanisms which are not that difficult. Of course, they have their costs. But think about the cost if you fill this with seeds, about the value. And then a bag of 30 euros. And of course, you need some equipment or rent some equipment to fill it or flush it and so on. It really can make a big difference if you are such a big producer, but Georgia is, of course.
Yeah.
But even on the small scale producers, you can use oxygen absorbers. If you use oxygen absorbers, put also a package of silica gel in there because of the moisturizer. But it's not too difficult. This is how it is flushed. So they make vacuum, so to get the air out, and then they put nitrogen gas in. They leave it for some time to mix it with what is left, and then they can do a second time. So, factors influencing seed longevity and storage. The most important is seed moisture content. Make them dry. And if it's vegetable seeds, 30%. If it's wheat, it's very expensive likely, and also risky if you have to do a long drying and hot drying to bring them down, but at least below 60%. Yeah, Lucy?
Yeah, it's funny because this seed moisture content, I was just going to frankly, I don't remember in any of the seed companies that I worked in that they were really measuring the seed moisture content for each lot before putting them in the storage. And yeah, it's such an important parameter, but it doesn't seem to, well.
But did they store them in a warehouse, humidity controlled warehouse?
Yeah, humidity controlled warehouse.
Yeah. Well, maybe I should not write here seed moisture content, I should write here equilibrium relative humidity.
Mm-hmm. Yeah, okay, yeah.
Then it's not needed to determine the moisture content.
Yeah.
If you know that they are in a safe relative humidity.
Yeah. Mm-hmm.
And what I also noticed, another company I was visiting in Asia, they had this very nicely stored. And then I came in the packaging room. Outside it was raining. In the packaging room were 20 people sitting. I said, did you measure the relative humidity here? No, why? Well, I see your seeds. You know, seeds are hygroscopic. Oh, yeah, see how open they are here in this bag. Mm-hmm. What do you think what happens if they are here? You put them out in the morning, and in the afternoon you're still filling your packages with the seeds. Mm-hmm. So that's really also there. Well, of course you have the workers doing the things, but really you have to think about the whole procedure. They don't know, they just do what is told. Take the seeds from the room and start filling.
Mm-hmm.
Yeah. And that's something which, well, as a manager for such a plant, you should be aware of what can be the effect. And it can be that the last package that day, the seeds were about 30% relative humidity in it. Mm-hmm. Yeah.
I don't think they can imagine that moisture inside the seed can go in this level so fast.
Yeah.
just in one day.
Well, it's
In
with,
some hours.
with corn. It will. That's a big seed. But what if you have lettuce seeds, of onion seeds? They're very favorable.
Yes.
They can really go fast. Yeah. Yeah. So equilibrium relative humidity should be low. That's the most important. Make them dry, keep them dry, also during packaging. Then the second effect is the storage atmosphere. I told you that if you halve the oxygen concentration, you can extend shelf life already with 70%. And if you go from 21 to 2%, well, you can calculate how much it is. But if you go to, if you remove all the oxygen, you can at least extend 10 times the shelf life. It's not needed for all seeds, but maybe even the germination may stay the same, but the figure may be getting more and more important. In my opinion, we need, for climate change, for other stresses we have, we need seed vigor is getting more and more important. With the seeds, you have strong seeds that even if there is more field stress, that they give seedlings, healthy seedlings. The third is the storage temperature.
Steven,
Yeah.
we have those lists from ISTA. When the seeds arrived, they should be for beans around 14%. So we crack the seeds, we measure and see, okay, 16, 20%, put it again in the dryer. And afterwards, we place it to the storage, 30%. And now I try to figure out whether this drying process is really needed for good storage. So because in the storage there will be
They will equilibrate in the storage.
yes,
Also,
so,
it's open, but it takes time. For beans, it's good you mentioned bean, and maybe in the past we had also discussions. Some beans, and that's mainly the bean you use for green bean to eat the fruits, the long beans. They are sensitive. They can be sensitive if you dry them deep. They get hard seeded. Get hard seeds, so they have difficulty in taking up moisture again. So there, you should take care not to dry them to 30%. It's good you mentioned that. Yeah.
Well, I can say something if it's helpful about beans. They were, okay, until today we were measuring the moisture content, not the atmosphere. So I found out with the beans that if they are too dry, it's not good for the beans. Why it's not good for the beans? Because in business, in commercial business, when you sell a bag of 25 kilos of beans, yes? The transporter will take it, he will move it to the center of transport, so he takes the bag from here, puts it there. Then the transport company takes the seat, he goes to the customer place, he takes from the truck the bag, at his shop. Why I say this theater is because when the seats are too dry, they break. And finally, when the next day the client opens to sell the beans, he sees a lot of broken seats inside, he calls you back, says, you don't have good seats, I don't want your seats because most of the seats are broken, take it back. So we found out that for beans, even if for vegetables it's 6 to 8%, my opinion, for the optimum moisture content. And to the open cultivation, I found out that the most convenient and good for wheat and open cultivation, it's something like from 9 to 10.5, somewhere there. For beans, even if they are vegetables, it's good up around 9, 10.5.
They contain less oil also, beans. Yeah.
I don't know about oil, but I know about the skin. The skin is more steady and more flexible.
I like it. That's what we also want to learn from the experience together. So thank you. Yeah. So yeah, so beans it's a special on two ways. So you can have the
Yeah.
hard seed coat and you can have the sensitivity to cracking. Yeah,
Yeah.
Stephanie.
Can you give indications if there's small seed batches that you want to freeze for long-term storage, or what would be the right humidity or the optimal humidity for freezing?
What our gene bank, the gene banks they have to store for very long term. So they dry the seeds here at 15%, so 15% relative humidity. Then they package them, vacuum package them, and then they store them in a -20. So that's what they do. There is some discussion whether 15% is not too low because it is ultra dry. I think, well, they do anyhow the vacuum packaging, so that may be why it is not that much a problem. Some gene banks, I think in Fort Collins, they do not use 15%, there is more 20% relative humidity, what they use, if I remember well. But there is some debate. But I think there it is, especially for long term, if you vacuum package, or even better flush, but if you vacuum packaging like this. There are gene banks also that store the seeds not in small aluminum foil bags. That's what they do here. Every time somebody asks for an accession, they just take a package. Now other gene banks, they have Kellner jars, so 1 liter glass jars. And if somebody asks something, they open it, take a sample, close it. I think for keeping quality, it's better to have the small batches because every time you open it, there's new oxygen in there. And anyhow, there is a lot of oxygen, even if it's at one moment the jar is half filled or even less. So there is, anyhow, it's always a lot of oxygen in there. And now we found out how important low oxygen levels are. That I think it's more advantageous to store vacuum packaged for long term. Yeah.
Can we go back to the beans and the no, it's the same slide, but you were talking about the beans, 30% relative humidity might be too low. And do you have any measurements? What would be ideal then?
Well, George said it's 9% moisture content, or no,
But
6, 7 for the beans.
That's for the
I
breaking,
understood.
right?
9,
That's for the breaking.
9 is okay.
Yeah.
9
I
and 10.
understood that, but I can't measure that. I can measure relative humidity. How would
But
that be
then
agreed?
you should do what we did today. Yeah.
Yeah.
You have to make a. Although there is also a let me see. This is the. Maybe I continue first. I have some. Tomorrow we will work also with a website where we can see what is the relation between relative humidity and the moisture content.
Yeah.
You can determine yourself, like what you started today, determine both the moisture content and the relative humidity, but so let me now continue first this, to finish this, the natural protection of seeds. I think this is slide 30 of 50. So seeds contain these protection mechanisms. I told this morning about the DNA, about these LIA proteins. Antioxidants are very important. And seeds are full of antioxidants, especially vitamin E. If you buy vitamin E in a health shop, the origin is wheat germ, so the embryo from wheat seeds. That contains also oil, the oily part, the oily part, and there's a lot of vitamin E. That is lipid soluble vitamin E, so that's important. We did experiments where we stored seeds at under dry conditions, and then we see that the vitamin E level really declines with storage time. It's oxidized. If we store them at a high humidity, that was around 60% relative humidity, vitamin E levels remain constant. And that is likely because it is regenerated. Vitamin C is used in its enzymatic activity to regenerate the vitamin E, so the vitamin E levels do not decline. In the dry conditions, it cannot be regenerated, there's no enzyme activity, and then it declines. So that's the physiology of the seed. In the glassy state, there's no enzyme activity, it declines, and if there is a liquid state, then the enzymes can be active and it can be regenerated. And vitamin C is important for it. I don't want to go in that detail too much. So these antioxidants are very important. Some seeds contain antiphenols to protect them. Think about cabbage seeds, the pungent taste of mustard seeds. That's to prevent that insects are eating them. That's also a protection of the seeds. Seed coats with low permeability to oxygen, or less, or like the red color in the rice seeds, that also limits oxygen penetration to the seed. Well, this is the vitamin E, the main antioxidant in seeds. It contains also vitamin C. Phenolic compounds are antioxidant, glutathione. Those all work like that. This is my for my home garden. This is the box I use in my home. So I have my seeds. I have a bag with silica gel, and I have a humidity meter just here. It's not in my home garden. I do not store without oxygen. That's then I have to open and close and put again. But this is just how I use it. I just noticed that I put it in the cellar, and it's hermetic closed, more or less, not completely. But I say, okay, well, the humidity is at 40%. Let's regenerate the silica gel, and that's the way how I keep my seeds dry for my home use. But you can, well, these are what we are using now, but you can use it's a multi-purpose equipment, this data logger, and yeah.
So you don't keep them cold?
Yeah, I put them in my cellar.
In your cellar, yeah.
Yeah, but you can also put it in the refrigerator, but my refrigerator is not that big. I'm not an American one. Yeah, but when it's, then I also have to put, like you said, if you take it from the cold, you have to wait an hour before you open it. Yeah. Well, control of the storage conditions. Of course, it's protection from direct sunlight, like with the dealers in Thailand, where I noticed that they put it on display on the outside. Optimal if you have a relative cool storage room, but this is the vegetable seed. It's 15 degrees Celsius. And take care that if your cold room or refrigerator has a high humidity, that is risky. If there is in paper bags or woven bags. We had, so this is the flushing or the vacuum sealing with for oxygen. These are these oxygen absorbers. I will show you tomorrow examples of these oxygen absorbers. If you have, who of you have visited Asia? No? Asia? Thailand, Indonesia. If you buy food, it's very frequently you find an oxygen absorber there. How to test the quality, the vigor. That's the last part. So, if you put it on filter paper, you can see it. Of course, then you have to also, if you do it on filter paper, you need enough water, not too much. But in filters, you can see what is happening. If you put in soil, you don't see that much. You only see the emergence. Take care also that you have to do it at an optimal temperature, or use a lower temperature if you want to do it as a stress test to see for the vigor. What we do is to see the quality of the seed lot. Is we often do we look in the morning, early in the morning, and late in the afternoon, so twice a day. That's a lot of work, but we get a better picture on the difference in qualities between seed lots. Because it takes longer if you have more damage, and it's diminished slower. You have, and then you can calculate the mean germination time, or the time to reach 50% of germination, or the uniformity, which for a farmer the most important, uniformity. And that is the time it takes between 25 and 75, or between 10 and 95. You create a germination curve. We have, you can do emergence test in soil. It's also a kind of figure test. You can, I told you about the membrane leakage test with the pea seeds. You can measure the respiration. There are different chemical methods, the tetrazoleum. There is a system where you can measure oxygen consumption by seeds, by individual seeds, a Q2, but that's an expensive equipment. What we measured is with seeds is also ethanol production. I told you the mitochondria are very sensitive to aging, to oxidation. And what we do, it's not that farmers can do it, but we put, let me see, oh, I have the pictures, let me show that. This is the germination curve. So what we use, so we measure several times a day, and then we can create with a software program, and you can download that for free. With that software program we can create a germination curve. And from that we can calculate how long it takes, the 50% of the germination. We can calculate how long it takes, the uniformity, and the total germination, of course, that's always, and we can calculate what we call the area under the curve. And all these parameters we can do statistics and see and compare seed lots. This is the membrane leakage test with P, where you measure the electric conductivity, the leakage water are there. And this is the chemical staining of if cells are alive. If they have respiration activity, a cell, and if the membrane is not leaky, it will turn red. And those cells are leaky or have no respiration activity. So it tells you about, it's a vitality stain. This is, I think, a cereal. So the endosperm is dead. I told you that dead tissue. So the endosperm is not staining. It has no cells, living cells. But this is the embryo, and the embryo, good quality embryo, is stained. This is the mitochondria. So we have the cell. This is I think an animal cell in general, the nucleus, Golgi, and we have the mitochondria here. The mitochondria for the energy production. This is the double membrane system, and the inner membrane here, and these are the protons, and this proton gradient is needed to produce the ATP. And you can imagine if that is leaky, you do not get that good ATP production. And then there is less aerobic respiration. So oxygen consumption is less. This is the machine that measures the oxygen consumption. You have, this is a microtiter plate. So who doesn't know what is a microtiter plate? You all know? Okay, yeah, that's good, that's why I ask. In fact, this is plastic. It's about this size. There are 96 small vessels, very small. On top of that is a plastic film fixed on it. And inside they put some water. You can put a seed on that, filter paper, some water. And then on the plastic, on the inside of the plastic is an oxygen sensitive layer. And then you measure from the top, so the blue laser light, and then you measure the fluorescence decay. So you measure what is the oxygen concentration. And then there is a movie, and this is the oxygen. This is the oxygen concentration during the germination process. So it starts with a high oxygen concentration. Let's see if it is running this or not. No, sorry, it's not. That's not running. Or maybe I can show you. This is from Rhino Research. They developed this system. So they can measure many individual seats, and they measure every 15 minutes, they measure the oxygen concentration. And then you get curves. This is the oxygen level, how it is declining. So you see some seats, individual seats, consume oxygen rapidly, and there are some seats for which it takes much longer. So you can see there is some variation in the seat quality. That's what they use this. This is not what small seat companies will use this equipment, but it tells you something how important the mitochondria are. This is something we developed together with a Canadian researcher. Energy production. In the mitochondria, you have the glycolysis, glucose goes to pyruvate, and there the NAD plus is circulated. And then if the mitochondria are not active, there is no regeneration of the NADH to NAD plus, and then it goes to anaerobic respiration, fermentation, so you get ethanol. If the mitochondria are not functional, you get ethanol production. If we are running very fast and there is not enough oxygen in our muscles, if that is not good, we do not produce ethanol. Maybe it's a pity, but we produce lactic acid. So we get acidification. It would be nice, it's alcohol. It's much cheaper to run than go to the shop to buy a bottle of alcohol. But it's not working that way with our body. Yeah? But seeds, they produce not lactic acid, they produce ethanol. When the mitochondria are not functional. And you can measure that with the gas chromatograph. But Wayne Buckley, that's the Canadian researcher, they said, well, he got a request from canola farmers in Canada. He said, well, we get the seeds from the seed companies, and we saw the seeds, and we are not happy with it. And then we go to the seed company, and he said, well, the seeds were good, look here, the certificate. And maybe there was 3 months in between the official seed test and the moment the farmer got the seeds, but that's farmer and nothing. So the farmer said, yeah, well, we put a lot of efforts in there. We like to test the seeds ourselves before we do the sowing. So we know if it's useful to do or not. So Wayne was looking how to test the vigor for canola seeds. And he found a publication where they measured ethanol production by canola seeds with a gas chromatograph. I said, well, I cannot tell the farmers you have to buy a gas chromatograph and to learn how to use a gas chromatograph. So, well, but if it's ethanol, there are also other ways to measure ethanol, and that's the police, who is by law enforcement. And if the police can measure ethanol, well, then a farmer should also be able to measure ethanol. The police has to do so many different tasks, so that it should be an easy, standardized way. So Wayne bought a breath analyzer, which the police is using. For alcohol.
Okay.
For alcohol, so for law enforcement, so to stop, will you please breathe. He replaced the tube with a needle, so he could, the machine, if you have a T-tube, you blow in it and then it sucks part of the air. So in place of that, he put a needle to suck in, and he put the seeds in the jar, put water, wait 24 hours, and then he measured ethanol, and that worked. So I thought, well, that's interesting. I like to learn the technique, so I went to Wayne to Canada, and then he learned me how it worked, and I came back and I said, okay, let's see how it works with cabbage seeds. It didn't work, and well, fortunately I have Jan, a very good assistant, and Jan said, well, let's see if we can increase the alcohol concentration in the headspace. So I said, when you drink cognac, you heat it up, so maybe it helps. So we increased the temperature to I think to 40 degrees, and we got perfect results. It's very interesting what we got. This is the breath analyzer. There's a needle, and we have the seeds in a tube. We add a certain amount of water, and we measure the ethanol. And We can measure already if we have a fresh seed batch of cabbage seeds, store that for 3 months in our lab, and we can measure that it produces more ethanol already. The seed quality is still okay, but we can see it starts producing ethanol, indicating that there is already, after 3 months, some damage to the mitochondria. That can be repaired, it takes time, so it's an indication that already there is something happening there. Yeah.
I didn't understand the needle.
The needle.
How you use it.
Well, normally what
I see
is,
the bottle.
so normally what you have here is a T-tube.
Okay,
Here is an opening,
okay.
and in it is a plunger.
Ah, okay,
And that sucks, normally if you have a T-tube, sucks the air from the T-tube.
okay.
And we want to suck the air from this bottle. So what we do is we put a needle for the opening,
Yes,
and we put a needle through the membrane because it is closed,
yes.
and then we can suck the air through the needle.
And then
And then we get
the air in the
the
machine.
headspace we get in the machine,
Ah, okay.
and the machine measures the amount of ethanol in that sample.
The seeds go to jail.
Yeah?
And then the seeds go to jail.
Yeah. Well, if they are wrong, they have to go to jail. Yeah. Yeah. This is, yeah. So then I promised to tell you a little bit about this invigoration treatments. That is, if you have seeds that are aged, it's not, I do not recommend that for if you want to use it for a crop. But still, let's say you have some germplasm there, and they do not germinate, but well, it is important in germplasm, or it is some material from your breeding program. Now, what you can do is to know that they are sensitive to inhibition. I told you about these membranes which are more stiff, less flexible. And if there is a big difference in water potential, it's very dry on the inside, and you have pure water on the outside, then this water goes in very fast and creates some more damage. So what you can do is you store your seeds for 24 hours at 100% relative humidity. That makes the seeds inside more humid. So the difference in water potential is less. The water will not go that fast, will not create that big holes in the seed. So that's a way that can be done. Again, not cold water, but lukewarm water, so that the membranes keep some of the flexibility still there. And then that you do for that you imbibe them with water, and then you start your incubation at the normal temperature. Yeah. Yes.
We also used to do that when we were sowing the pumpkin seeds for selection, like because we only would have like 3 or 4 or 5 seeds per line or per number, and then we would.
You do this.
Yeah, to make sure that they would all germinate.
Yeah. That's very important material that you want them all. Yeah.
But yeah, you wouldn't do that with seed.
No, but it helps to give them less stress.
Mm-hmm.
Okay. Then the second solution is to use seed priming. So you start with the 24 hours humidification, and then you mix the seeds with water, lukewarm water, not too warm, for some time. And this is a very simple method of priming. And then you remove the adhering water. So the seeds are wet, but they cannot take up more water. And then you keep them at optimal temperature for a few days with oxygen, because they're wet, they need oxygen. And then you can sow them, or you can add water. Normally, commercially, priming the seeds are dried. On-farm priming in India is they just mix them with water, and the next day they do the sowing, and they get a better germination also. But this is a simple method to save some of your seeds. Yeah, to get a better performance.
Would you do that with lots that you sow mechanically?
No, then because they are wet here,
Yeah.
then you have to re-dry them.
Yeah. So
Yeah.
that's only in case you.
Yeah.
you
And
can
this is a very primitive way.
Yeah.
If you really want to do a priming at your company, you
Mhm.
really have to make experimentation what to do, or you go to a company who's doing the priming commercially, but it's expensive.
Mhm.
Here, the 24-hour humidification is at
That's the
100%.
first start, which from the first step.
Yeah.
Yeah, yeah. It's just with the aged seed lots that you want to save. So, I told you about this. Mature seeds have the maximum protection, and this protection is removed during imbibition. You make the seeds wet, so the seeds start to remove, and also during priming. And commercially primed seeds often have a lower shelf life. I gave the example of for the celery seeds, the primed celery seeds. They're really short shelf life. And look again, compare that with the protection of the washing machine. The screws are gone. I don't know where I left them for fixing the centrifuge. And then I want to move. And then I have to move. Let's see if it's working. It is not working anymore. Let me see. I restart again because it's a nice. Oh, let me see. Now it's working. Yeah. So they're moving the washing machine.
Great. Oh no.
Yeah. So that's why.
Can happen.
Don't let it happen to your seeds. Yeah. Okay. So the best storage conditions, again, dry. This is the best. It's not economically the best, but this is for your seeds. Reduced oxygen levels, reduced temperature, and well, which to turn, which parts. You have to decide yourself. What are the costs to do that, and what is the value, and what equipment you have available. And there is a difference between germplasm, like in the gene bank, which is a very expensive seeds, individual seeds with the costs in production. Horticultural seeds are also more expensive compared to most agricultural seeds. And they have a lower volume, so it's easier to store them under more controlled conditions. So what did we discuss? We discussed seed aging, quality losses during storage, damage, moisture effects, temperature, oxygen, and how to control these factors. We talked about data loggers. We are experimenting with data loggers. We have storage of germplasm and breeding lines, and in a few minutes we will go to the gene bank. They are waiting for us. There is these invigoration treatments like humidification and priming, and why prime seeds have a lower shelf life.
And washing machine transport.